Hey, this is Mr. James. In this video, we're going to be going over the solutions to the properties of quadrilaterals review packet. We'll be talking about all the different solutions, so before you watch this video, make sure that number 1, you've tried every single problem, and number 2, that you've checked the answer key. If for some reason you haven't done this packet yet, or tried it at all, and you're watching this video, please pause now before the solutions start coming out. If you only have a few problems to look at, or questions on, make sure you fast forward the video so you're not watching problems that you already know how to do. Just fast forward to the ones that you have questions on. Solutions will start coming out in 3, 2, 1. Number 1 says the quadrilaterals below are parallelograms. What are other possible names for parallelograms? A good way to approach this kind of problem is to think about the tree diagram. As you can see, parallelograms are only types of quadrilaterals, and there's nothing else above them. As a result, the only other possible name for a parallelogram is a quadrilateral. Number 2, list 3 properties of parallelograms, such as congruent sides, bisected angles, and perpendicular lines. As you can see, I've already written some of the parts of these out with some fill in the blanks. So if you haven't already tried this, pause the video now and copy down what I have and fill in the blanks yourself. The answers will come up in 3, 2, 1. A. Opposite sides are congruent and they're parallel. That means that sides like this are congruent and they're also parallel to each other in a parallelogram. B. Opposite angles are congruent and consecutive angles are supplementary. So that means that angles like these two are congruent to each other, while angles like these two right here will be supplementary. They will add to 180. C. The diagonals bisect each other. So remember that the diagonals, these lines that cut the segments that cut through the center, will be congruent to each other, just like that. They cut each other in half. Let's take a look at the problems for 3. If you haven't already done these, try now. The answers will come up in 3, 2, 1. We mentioned previously that the consecutive angles in a parallelogram are supplementary, which means they add up to 180. So if you take 120 and subtract that from 180, you'll be left with 60. The angles across from each other, these opposite angles, are congruent, so B will also be 120. And this angle right here will have to be 60 as well. But since it has a variable, we can write an equation for that. 4x equals 60 degrees. Or, dividing by 4, we get that x equals 15. For the second one, we remember that the opposite sides are congruent, so D will be 6 centimeters. And over here, this right here will be 5 centimeters, but again, we've got an equation to write. 5 equals 2y plus 1, again, because the opposite sides are congruent. Subtracting 1 from both sides gives us 4 equals 2y, and dividing by 2 leaves us with 2 equals y. We also know that the diagonals bisect each other, which means that this half of the diagonal will be converted to this half, which means that f is also 3 centimeters. Lastly, in this parallelogram, we can do a few things. Since the top and the bottom are parallel, this 30-degree angle can be copied over to here. H and this original 30-degree angle are what we call alternate interior angles, and alternate interior angles are congruent if these lines are parallel, which they are. Lastly, we have a triangle right here with 45 degrees, 30 degrees, and a missing angle G. We can take 45 and 30, add them together, subtract from the total 180 degrees in the interior angles of that triangle, and get that G is 105 degrees. Taking a look at number 4, the quadrilaterals below are rhombi, or rhombuses. What are other possible names for rhombus? Again, looking back to our tree diagram, we can see that a rhombus is a type of parallelogram, and also a type of quadrilateral. And so for 4, a rhombus could also be called a parallelogram or a quadrilateral. For 5, list 3 properties of rhombi that are not properties of parallelograms. Again, I've got some fill in the blanks here, so if you haven't already completed these, try copying them down and filling them in yourselves. The answers will come up in 3, 2, 1. For A, we have that all sides are congruent in a rhombus, which means that all of these sides are the same length. B, the diagonals are perpendicular, which means that when I draw my diagonals in, I'll have a 90-degree angle right in the middle, right where those diagonals intersect. And C, the diagonals bisect the angles, which means that all these diagonals, when they come in, they cut the angles of the original rhombus in half. So these two are the same size, these two angles are congruent, the same measure. That's number 5. Now let's take a look at some of the answers to number 6. Label these properties in each diagram, and they're all rhombuses. So we start with A. Remember, we said that the diagonals of a rhombus bisect the angles. So if this angle is 60, A will also be 60 degrees. For B, we said that the diagonals of a rhombus intersect at a 90-degree angle. They're perpendicular, so B will be 90 degrees as well. As for C, well, if we look here, this is 60 degrees, and since the opposite sides of a rhombus are parallel, just like in a parallelogram, A and C are alternate interior angles, and C is 60 degrees. What about D? Well, we can do a little bit of work here. In this triangle right here, we have a 60-degree angle, a 90-degree angle, and a blank angle. We can fill that in with 30 degrees because all the angles should sum up to 180 degrees, 60, 30, and 90. Then, since we know that the diagonals bisect each of the angles, D will also be 30 degrees, since these two angles in a rhombus, only in a rhombus, should be congruent. For the next one, we can fill in E and F with both 12 meters because we know that all the sides of a rhombus should be congruent. But this last side has an algebraic expression, so we'll need to write an equation here. We know that this side should be 12, so we can write the expression, or the equation, 12 equals 5x minus 3. By adding 3 to both sides, we get 15 equals 5x, and by dividing by 5, we get that x equals 3. For the last one, it seems a little confusing because there's only one equation here. But remember, just like in the first one, that the angle here is 90 degrees, that the diagonals are perpendicular to each other. They form a right angle and 90-degree angle. So 3y plus 15 should equal 90 degrees. We can write that out. 3y plus 15 equals 90. We can subtract 15 from both sides to solve for x. Getting 3y equals 75. Dividing both sides by 3, we obtain that y equals 25. Now in 7, the quadrilaterals below are rectangles. What are other possible names for rectangles? Just as before, we can see a rectangle is a type of parallelogram, since it's below it, and also a type of quadrilateral. So we have parallelogram and quadrilateral for number 7. For 8, we need two properties of rectangles that are not properties of parallelograms. Again, the answers will come up in 3, 2, 1. For 8, we have that all angles are congruent or right or 90 degrees. So in a rectangle, this is something we've known for a while. We can fill this in just like that. And B, the diagonals are congruent. This is a little bit newer. But that means that all the diagonals not only bisect each other, but are all the exact same length. So let's see how we can use some of these properties to help us with number 9. Well, to start, we know that since this angle is 15 degrees, we can mark that this is a 90-degree angle. And so to get this angle right here might help us later on. 15-degree angle minus 90 degrees leaves me with a 75-degree angle. Now what else do we know? Well, we know that all of the diagonals are congruent, which means that a rectangle has a bunch of these isosceles triangles built into it right here. And what do you remember about isosceles triangles? Well, we remember that the base angles are congruent. So if 15 degrees is here, D will also be 15 degrees. Again, they're both base angles of this larger isosceles triangle. A will be found the same way, right? We have another isosceles triangle right here, and since we found out that this angle here was 75 degrees, by subtracting from 90, A will also be 75 degrees. Now let's turn our attention to these middle angles. We've got this triangle here with degrees 15, 15, and one missing angle. We can add them together, get 30, and subtract from 180 to get 150 degrees. Again, all of these angles should add up to 180 degrees, so this middle angle should be 150. C is the vertical angle to that, so C will also be 150. And B is a linear pair, which means B will be 30 degrees. Remember, when I say linear pair, I mean two adjacent angles that add up to 180 degrees. They're supplementary. Now, taking a look at the next one, we know that all the diagonals are congruent. And so we have that this whole diagonal is 4x plus 2, and this half of the diagonal is 8 plus x. Now, you might be tempted to set them equal to each other, but they're not equal. 4x plus 2 is much larger than x plus 8. That means we'll have to double x plus 8 in order to set it equal to 4x plus 2. So I'll write 2 times x plus 8 equals the 4x plus 2. Now you could also write that as x plus 8 plus x plus 8 equals 4x plus 2. But in either case, you'll be left with 2x plus 16 equals 4x plus 2 after you combine like terms. You can subtract 2x from both sides to get your x's together and be left with 16 equals 2x plus 2. We can also subtract 2 from both sides, okay, to get 14 equals 2x. And then lastly, dividing by 2, we're left with x equals 7. This third one looks more challenging. We have one diagonal, one side, and we're asked to find the other side. Now, you might want to just start labeling what you know. I mean, we know that should be a right angle in all the corners, right, all the vertices, all the angles here. And suddenly, maybe you notice that, hey, right here we've got a right angle, or a right triangle, excuse me. And so, if we've got two sides of a right triangle, how can we find the third? Well, we could use Pythagorean Theorem. So we'll have e squared, being one of the shorter legs, plus 8 squared, the other leg, equals 10 squared, the longest side. 8 squared is 64, 10 squared is 100, and I can bring down the e squared. Subtracting 64 from both sides gives me that e squared equals 36, and I take a square root of both sides to get e, and e is 6. So this is 6 centimeters right there. Quadrilaterals below are all trapezoids. What are other possible names for trapezoids? Well, unfortunately, looking at the tree diagram, we notice that trapezoids are only a specific kind of quadrilateral and nothing else. What about the properties for number 11? Pause the video here, otherwise the answers are coming up in 3, 2, 1. So trapezoids have one pair of parallel sides, and two pairs of consecutive angles are supplementary. Remember, since these two parallel sides, also called the bases, are parallel, these angles here form what we would call same-side interior angles, and so they're supplementary, or they add to 180. For isosceles trapezoids, we have slightly more specific properties. The non-parallel sides are congruent, by definition, and what that causes is the base angles, this angle and this angle, to also be congruent. That's not written down here, so I'll add it in just like that. So the base angles are congruent. So again, maybe that angle and that angle are going to be the same measure. Lastly, the diagonals are congruent, which means that this length right here is the same as this length right here. They are congruent. When we take a look at this first one, you might be tempted to say that A will also be 140, because 140 and A are those congruent base angles. But watch out, this is not an isosceles trapezoid. You cannot do that. However, we do know that A and 75 will be supplementary. They're those same side interior angles. So A will be 105 degrees, and B, looking at 140 and subtracting from 180, leaves me with 40 degrees for B. This next trapezoid is an isosceles trapezoid, so C is 85, again because the base angles are congruent. D will be supplementary to 85, so subtracting from 180 gives me 95. And right here, 8x plus 7 will be congruent to 95, again because they're both base angles, so I can set up the equation 95 equals 8x plus 7. Subtracting 7 from both sides gives me 88 equals 8x, and dividing both sides by 8 gives me that x is equal to 11. This third isosceles trapezoid had a little bit of an error in it, so make sure that there is no 15 here. If there isn't 15 degrees here in your diagram, please cross it off now. We will not be using that. So taking a look, well, we know that E is 6 centimeters because this is an isosceles trapezoid, and these two legs will be congruent. So E is 6 centimeters. What about the angles? Well, we do know in an isosceles trapezoid that these diagonals will be congruent. So this creates an isosceles triangle right here, similar to what we had in a rectangle. And so F will be 40 degrees. Again, since we have this triangle, we know that the interior angles will sum up to 180 degrees. So we can take 40 and 40, subtract that from 180, and be left with 100 degrees right there. H is supplementary to 100, which means that H will be 80 degrees. Forms a linear pair. Again, over here we could put 80 degrees. Lastly, we have that 35, 80, and G form a triangle, and so subtracting from 180, we get that G is 65 degrees. For 14, a kite is only a quadrilateral. The answers to 15 will be coming up in 3, 2, 1. So for a kite, we have A, that there are two pairs of congruent sides, as marked in this figure right here, but there are no parallel sides. For B, the diagonals of a kite are perpendicular, similar to a rhombus, and it also has one pair of these opposite angles, here and also here, that will be congruent. So how do these properties impact the angles and lengths in a kite? Well, let's find out. In this kite, we've got that this angle is 35 degrees, and this angle over here is 90 degrees. We need to find what A and B are. Now, we know that A and B will be congruent, but we don't know much else. However, do recall that the angles in a quadrilateral, no matter what quadrilateral it is, always add up to 360. So we can take 360 and subtract off 35 and 90. And we get that there's 225 degrees left to split between these two angles. Since they're congruent, we can take 225 and divide it by 2 and find that A and B are both 117.5 degrees. So that's 117.5 for both A and B.